Hello and welcome to this video presentation of what's new in GLOBEClaritas V6.7 release. A lot of the work we've done on this release has been focused on improving, simplifying and making it easier to QC the refraction statics process from its initial auto picking and first break picking through to generating the statics and displaying and understanding how good a solution you have achieved. So I'll initially start off by showing you the improvements we've made to the auto picking and the QC of those auto picks. So if I open up the SV application and pull up a set of shots on which I've not picked any auto picks or first breaks at the moment. So if I click on the auto pick module, Okay, I'll get an initial set of picks. Now previously these picks would have been saved out as a .pic file, and now they are saved both as a .pic file in the relevant directory, but also they are automatically saved into the trace header of an HDF5 file if you are using HDF5 format. And this happens as soon as I click the next button on to move along the line. And to show you another feature we've added in, which is basically enabling the aerial and SV applications to monitor or watch the HDF5 file and update when any changes have occurred to that file. I will bring up the aerial application, display the header where the first break picks are saved, which is first break time, and I'll display this based on shot ID and channel. So at the moment you can see there are no first break picks in the trace header. It's all blank, all zeros. If I then just click the next arrow on this, you'll see that the display updates with the first shot ID having been picked and having first breaks picked on it. If I then click off from the utils menu of SV, auto pick all shots, and then bring aerial up, you can see as the data set runs through and is updated and the picks are made on each shot, then the aerial application updates the display in real time pretty much. In this way you can keep an eye on the quality of your first break picks, hopefully identify an early stage any anomalous picks that you might want to go and review and look at. So it gives you an additional QC as well as looking at the basic display within SV itself. One of the reasons we wanted to do this was to enable the refraction statics applications to read both the geometry and the first breaks from the seismic trace header, and then also at the same time write information out directly from the refraction statics package into the HDF5 file as well. And I'll talk you through that in a minute. So this basically makes running the refraction statics process a little easier, simpler, and also then QC of that refraction statics also becomes simpler. So I'll just let this auto picking finish. So you can see that now the aerial application is fully populated with picks everywhere we have live data. You can also see in areas where there's probably places that you'd want to go and QC the shots where they've got these outlying values, also where there's no picks appearing. You could either go in, update your auto picking parameters to more successfully pick the data, or go through and make manual changes, and again these will update into the trace header. I will now close that, quit and discard. I will leave the SV application open and go to the statics menu and select 2D RefStat. Now you'll see basically on the RefStat application there are two buttons for the selection of first break picks and HDF5 files. So you can, if you want to, continue to use pick files and geom files and select those as your inputs, or alternatively you can click on the HDF5 button select the dataset we've just saved our picks out into, and from which it also has the geometry information available, and click OK on that. And then we get our refraction statics windows up, and displays our first break picks which have come out of the seismic trace header. We can evaluate what our first initial model looks like, but just for the example of what we're doing here, I'm going to click on Calculate, give it a Model 2 name, and 4 iterations. I'm also going to add into the SV application to display header names. So what I'm going to display is first break time and model break time. So when I click that OK, at the moment you can see that the red picks for the first break times are active and running across because we've actually picked those and they are exist in the header. And then the purple display for the model break times is all zeros at the moment because we've written nothing out. If I click OK on the rest of the application, it'll run through its iterations. And when it's finished that, it will write information like the model break time and the statics it's created out into the seismic trace header. And when I move on to the next shot, you can see that now we have the modeled first break picks displayed on the seismic data. And then basically what I could do is run further iterations and calculate again and again, and each point it would update those modeled first break pick times, and we could display and see how well the refraction static process was iterating towards a suitable optimal final solution. We could also, at each point when we've created some new statics, having run through one of those calculation stages, we can click on the statics button, and we can either read in a shifts file or select from trace headers. So there's now a bunch of different trace headers for the source and receiver, modeled statics, and our short wavelength residual statics. And I can click OK. And as you can see, I can now basically toggle on and off the statics that have been created and QC again on the fly how good those statics are. And I can go to any location in the shot and again in the dataset, and again toggle on and off and confirm how good my static solution is. And in that way, more effectively determine when to stop updating the statics solution, and when I feel I've got a good result and I can leave it as it is. So this capability is both in the RefStat 2D and the RefStat 3D applications, so works both for our 2D and 3D refraction static solutions, and will allow you to easily QC both your model break times against your actual pick times and your statics as well, allowing you to optimize your solutions quickly and effectively. The static supply button parameter form also will allow you to apply an elevation static as part of your correction, so you can click on shift file and select your floating datum correction, supply your seismic reference datum and replacement velocity, and apply those as well in the SV application. That's all I want to say about that. Just to say that basically when we create, when we run either the AdJOM processor or create a brand new data set from a, say, a SegY or SegD input and write it out to HDF5, then all the required headers for writing in the first break pick times and everything that RefStat 2D, 3D need and write to are created in the HDF5 output file that you create. So they're always available and will be populated if they exist. With AddGeom, it will create those headers if they don't exist in the input dataset. So if you read in a size read or a disk read dataset that doesn't have those headers existing at that point, then it will create them on the fly. What else? We'll also talk quickly about the Add SPS module. So the Add SPS module, which has been around since the last release, allows you to merge source receiver XY coordinates and the relationship information into the seismic trace header without creating a geometry database. Our initial implementation required that the data had shot ID channel information in the trace header and merged based on that. We've made an update to the application to now allow it to key on shot peg and rec peg as an alternative. This is to facilitate use by acquisition contractors or processing houses where they've got data recorded by nodal systems, which they may get in-house or out of the field without shot ID and channel information. So it allows it to basically merge based on the shot peg and rec peg information that is in the trace header of these nodal data sets, and import the source receiver XY's elevations, etc., into the trace header like that, as well as creating the shot ID and channel headers as part of that process. Another update we've made to the Add SPS module is to incorporate a peg multiplier parameter. So for some surveys, the source location is calculated as a midpoint between receiver pegs. So the receivers might go 101, 102, 103, 104, and the source position pegs might be 101.5, 102.5, etc., etc. So the peg multiplier allows you to basically define a factor to multiply the source peg location header by to get an integer value that can be stored in our seismic trace header. This peg multiplier exists as well within the geometry tool, so we are consistent across all applications. And show you an example job flow for the Image K3T application. So we've done quite a lot of work on the Image K3T module, and these updates are both available both in the standard Claritas module forms as well as in the Image Suite application. So the work we've carried out on Image K3T this time around is to update the tapering that was performed. In our original implementation, we'd basically defined a taper, which was fairly mild, and there was no user control on that tapering. Consequently, our migrations could on occasions look a little noisier than other software would produce. So at the request of one of our clients, we've incorporated a taper parameter which allows the user to control the amount of tapering that they want to apply from 0% through to 100% tapering of the operator. So basically you just type into this form here, this parameter form here, the amount of tapering you want to apply. So again, gives you more control. Best way to evaluate what sort of tapering you want to apply is to run standard impulse response tests on using the algorithm and to see what effect the different taperings have. We've also improved the anti-alias filtering capability. So again, in the previous implementation of K3T, the anti-aliasing was very much an on or off, a yes or no capability. we now give the user the ability to control the amount of anti-aliasing applied as a ratio factor. So if you don't want to apply any anti-aliasing, the ratio you apply would be 0.0. Typically, the ratio that we would recommend would be a ratio of about 1.0. But depending on how aliased your migration is coming out, you might want to apply more, maybe up to 1.5. We would suggest that beyond 1.5, that's sort of in the region of a ratio of 2.0, is likely to be a little smeary and maybe make your data look a little over-processed and start adversely affecting fault definition on the output, but up to you to test and decide what your optimal anti-aliasing is for your data set that you're using at that point. Other things we've implemented that don't have user control are previously the outputs from our migration were not normalized relative to the input data. We've again updated as a request from client so that the output from K3T is now normalized to the input amplitude values, and we also apply an edge effect scaling capability that is again automated and calculated on the fly by the application. All these updates, as I said, are available both via the module and through the image suite application itself. Next thing I would like to talk about would be our new 3D pre-stack depth migration algorithm. So again, at the moment, this only exists as a module within Claritas itself and hasn't been ported into the image suite application as yet. Currently, it takes HDF5 input, but can output HDF5, CSegWi, or SegWi revision 1, depending on your preference. The velocity files it takes in can be in our internal Claritas format, or again, SegWi revision 1 format. Uses either a 3D grid file or a Claritas geometry database file. Same input parameters in terms of inline, crossline control and offset definition. And then in terms of parameterization, we have operator controls for aperture, near offset protection, angle or degree. Tapering has been implemented as well, same as K3T at the moment. Maximum depth you want to output your depth migration results to, your sampling rate for that output data, and a resolution parameter for how well sampled the travel times are, and then obviously our standard MPI and process controls as well. We give the users the option of selecting an output format, and particularly the SegWi revision 1 output, because Claritas hasn't developed the velocity model building capability within the software. We're expecting users to have a third-party software to provide this capability. Our recommendation will be to try the GLOBEClaritas OpenDetect Pro interpretation suite and their velocity model building capability. So that basically by giving you SegWi revision 1 output format, it means you can write your depth migration data set out in SegWi revision 1 and immediately take this through and into the OpenDetect Pro application and the VMB build, a velocity model builder, and start updating and improving your velocity model. And then take that data, export that updated velocity model as a SegWi file and put it into your next iteration of depth migration. This K3D has been available in our current beta releases as we've moved towards this 6.7 release, and we have had some positive feedback from clients who have already tested and used it, but obviously we look forward to hearing from anybody who wants to let us know their feelings and thoughts on the new depth migration. Right, I will now go to the wavelet tutorial and basically talk you through another improvement that we've made to the software. So previously with the wavelet application, the users needed to reformat any data, any far-field signature they received from a client, which would typically be in Gandalf or Nucleus format, into either our internal ASCII format or using the XASC SegY tool, convert the supplied signature in ASCII format into a SegY file that could be read into the application. As part of this release, we've now allowed you to basically read in your supplied far-field signature in whatever format it is, select the format of the that it's been supplied to you in, either Nucleus or Gandalf format. As you can see, each you can select from the drop-down list, and then read it directly into the wavelet application without any need for you to reformat into our ASCII format. And as you can see, that was a Nucleus format, and it's read in directly into the wavelet application, and then you can start running through your typical wavelet processing flow to create your minimum phase or zero phase conversion filter. One of the advantages with this route is that because you're reading directly from the format supplied in Nucleus or Gandalf, is that it's also extracting the T0 point from that file and correctly setting that in the input file, rather than you having to manually set that when you read the data in from our format. So it makes life a lot simpler. We also had a user request to improve sort speeds for the size read module. So after some profiling and review of the code, we made some improvements to the HDF5 data format and how size read worked with this data. So if I open up a data set in SV, or bring up the SV parameter form, and then click on the view button, I can show you some of the changes that we've made to the application, which also means that there's less of a need for users to run a range job. So one of the ways we looked at speeding the size read up for sorting was basically getting it to read only those headers where the header values changed. So what we implemented was basically a min-max parameter, or min-max information into the size read data HDF5 data sets. So now size read only basically reads and interacts with headers where the values change through the data set. So in any of the HDF5 data sets that you create from V6.7 on, you will have basically a listing of non-zero trace headers in the HDF5 file. And also this means you no longer need to run a range job for finding out your minimum, maximum inline crossline ranges or offset ranges. And it also has given us a significant speed up on the size read sorting, because it no longer reads these headers that are either zero or constant. It basically understands the constant value that's in the trace header and basically recreates that header at the end of the sort with the constant value in it, and doesn't need to read it. This has given us a significant improvement on sort times for HDF5 datasets, and along with suitable parameterization of the trace header chunking and data chunking sizes, can give some pretty good results in sorting. And finally, I'm going to bring up the release notes and talk you through some of the other improvements that we've got. So I've covered most of the improvements with some of what I've discussed already on here. We have a new module called lat-long XY, which enables you to, and I'll pull up the relevant section just to talk about it, be a little easier. All right, so the lat-long XY process module takes one or two pairs of trace headers, which will be defined as latitude and longitude in our seismic trace header. They're likely to be source and receiver XY locations, and converts that position information in latitude and longitude to Cartesian easting and northings. So the lat-long XY module relies on the Proj4 coordinate transformation software for applying that transformation. So you'd need to download and install that alongside, but basically allows you to convert, if you do have a data set that's come in with just sort of lat-long information as to the positioning, into Cartesian coordinates, which are a lot more useful for actually processing the data. There's also a new FK filter module, which provides another option for FK filtering of input ensembles. We've also added some updates. So I've discussed the add SPS one, and another one that's worth talking about is the Snoop module. Basically, Snoop prints out some diagnostics on how the processing flow is running, tells you how long it's taking between each X number of ensembles to go through. We've also added in some additional information. So it prints out some additional timing information, including elapsed time and trace throughput rates, etc., for the process up until the Snoop module, and creates a dot profile text file, which you can then use the xjob_profile utility to graphically display. So it allows you to better understand how efficient your job flow is, and maybe sort of optimize a little better if you feel that your job flow is not running as fast as it should be. Other changes, again from user request, is to the auto pick module. So we've basically begun to harmonize the auto pick module with the auto pick capability within SV, so that you can parameterize and optimize your auto picking ASV and get a optimal auto picking routine defined, and then transpose that into the auto pick module, so that if you've got multiple lines to run or a large 3D volume that it's take too long to run it interactively within SV, you can parameterize the auto pick module and have that run the auto picking as a batch flow. And again, so it now has the majority of the more common auto picking functions and parameterization exactly the same as the SV application, and also writes out into the same first break time trace header as the SV application does. So again, the data's then fit and ready for input into the RefStat applications. So we think it's a pretty big release, again, with the addition of the K3D pre-stack depth migration algorithm, which we feel is obviously immensely valuable to users. The improvements to K3T, and then generally the streamlining and making more efficient the refraction statics workflows. And it's what we're going to try and aim to do a lot of the time, is to improve the workflows for things like refraction statics, start to do away with the need for some of our support files, our ASCII text files, by incorporating the information directly into the HDF5 header, and utilize some of the benefits and capabilities of HDF5. Thank you for taking the time to watch this video. And if you haven't already downloaded the V6.7 of the software and you're a current supported client, then please contact us and we'd be happy to supply a download link. Thank you and goodbye.